Hello everybody, how are you? Welcome to Ask Math Anything. If you haven't been here before, what we're going to do is we're going to answer a lot of random questions that people ask about mathematics, usually ranging over algebra and geometry. If you have been here before, welcome back. I actually just realized something. And what I just realized is because we don't do this live stream every single day anymore, I realized that I didn't set up the part which lets me see what you guys are typing. Hang on 1 second. Let me just plug in one computer over here. All right, so that's starting up. Hang on a second. I see what's going on. Actually, as some of you know, I'm running the United States National Math Olympiad training program at the same time. So it turns out that all of my devices were actually signed in for the Math Olympiad training program. One moment. Finally. Okay, very good. Come on, let's see this. Let's see this. Oh, good. Oh, good. Oh, good. Now we're here again, and now I see the usual setup again. That's good. And I can see all of you. Fantastic. Well, I can't see all of you. I can just see what you're typing. We're all good again. Right. So actually, if you're curious, what I was doing is because when we're teaching remotely here for the Math Olympiad training program, we have lots of people studying from home. And the way I like to teach when there are lots of people studying in this virtual classroom is what I usually do in this studio is I go and get a bunch of different computers and I set them up on different sides of the studio. So they're all kind of facing each other. And each of those happens to have maybe about 4 people who are in it. So it's like little groups of 4 people. So that's why what was going on was that my entire set of laptops here in this studio was all configured to be this virtual classroom where I could stand in the middle and walk to each side to kind of talk to this group of 4 students over here or that group of 4 students over there. All right, but we're here to do Ask Math Anything now, so we're going to switch all the way back. Will the live streams in August be more frequent? I don't know yet. The way that I'm dealing with all of this is I'm just dealing with the work that comes in, but I do want to try to be able to see you guys every so often, like now. So let's go and do some math. Let's do some math. Okay. What kind of questions do we have today? I'm trying to find a good choice that we can use to start with. Daksh Gupta has a question. It's a puzzle to try to figure out what these 4 numbers are. I wonder. Let's go and find out. So Daksh Gupta says, the mean of a list of 12 numbers. So there's a mean of 12 numbers is equal to 13. So the mean of 12 things is 13. And also, what else do we know? Oh, there are modes. The modes are A, B, C, and D. That's interesting. There are multiple modes. Are A, B, C, and D. What does it mean to have more modes? So mode means the number that appears the most often. And if 4 numbers are all the mode, what that would mean is that would mean that you have 4 numbers that all appear equally often. Oh, someone said there's a scratching sound. You know what? I think I know what's going on. It might be that the microphone is touching the base of this. Let's try that. I wonder if that will work. So what is going on is that I was doing lots of different recording things, and the microphone was touching the same stand that I put my computer on. So when I wrote with the computer, it caused there to be some kind of a rustle on the microphone. So I think it's okay now. Right, but let's keep going. Now we know some more. We also know that A plus 2, okay, so we also know that A plus 2, B minus 6, C plus 1, and D minus 3. Whoa, these are all distinct numbers in the list. So these are all distinct numbers in the list, but none of them is a mode. It also says that none of them are modes of the list. None are modes. If that's the case, then the question is, what is A plus B plus C plus D? Okay, how do you do a question like this? So this is a question which is about, I guess, some statistical things like modes. So when I look at something like this, I say there are 12 numbers. And if there are 12 numbers and there are 4 modes, then what could it be? Could it be that each of these numbers appears 3 times? That would be one way. Maybe each of these numbers appears 3 times. How many people think that if I've got 4 modes in 12 numbers, that each of those numbers should appear 3 times? That's actually what I thought at first. Except that then I read the next thing. And the next thing said that here are 4 other numbers and none of them are modes. So if none of these are modes, then it can't be that I used up all 12 of my numbers already by saying 3, 3, 3, and 3 of those. So that means that I maybe have 2 of each. Oh, could it have been that I have 1 of each? You see, I'm trying to narrow things down. I know that it can't be that each of these appears 3 times, because otherwise that wouldn't be true. Could I have that each of these appears 1 time? Could that be it? Can you have the modes be the numbers that appear just 1 time? Well, also no, because you have to make sure that that is, that's the most common number. And if there are 4 most common numbers, all of which appear just once, that's a problem. That would actually mean that you have 12 most common numbers, right? Because there are 12 numbers. So now I know each of these appears twice. So now what I know here is I know that each appears twice. Okay. Now I think I can probably try to figure this out. I have that the mean of 12 numbers is 13. And I have all of these as different numbers in the list. Aha! I think I can figure this out now. So I think we can say that if the mean of 12 numbers is 13, then what's their sum? Their sum is 12 times 13. Let's do that. If the mean of 12 numbers is 13, then their sum is equal to 12 times 13. What's 12 times 13? Some of you who have watched some of my live streams know that I like to multiply numbers in the teens by doing this trick where I say, add 2 and 3. That's 5. Sorry, that's, add the 3 to the 12, and that makes 15. And then multiply the 2 and the 3, and that makes 6. We actually talked about this at one of our live streams earlier too. But so we have 156. Some people say, memorize it. I guess Tiger Lee happens to know that it's 156. That's one way too. Is that Arthur Benjamin's trick? Asks Min Ko. I don't know. I learned that trick a long time ago when I was just doing math contests myself, and it worked pretty well. Okay, so now I know that the sum of these numbers is 156. I know that there's 2 of each of those, and then here are all some new numbers. So now I can try to solve for A, B, C, and D? Well, no, it's asking me what's the sum, and that makes me happy, because I think I can get the sum out of this. Let's write down what I know. I know that if I take 2 of A plus B plus C plus D, this, by the way, is the sum of the modes. There's 2 of each of them. And now let's add this. Plus A plus 2 plus B minus 6 plus C plus 1 plus D minus 3. What's this supposed to be equal to? This is all supposed to be equal to the sum, 156. Hooray! So this is supposed to be equal to 156. Now, why am I happy? I'm happy because I can get A plus B plus C plus D, because here's 2 of them, and here's 1 of them. So that's perfect. Altogether, I have 3 A plus B plus C plus Ds. And what else is left over? I have a plus 2, a minus 6, a plus 1, and a minus 3. So let's add those together. Minus 4, minus 3, minus 6, I think so, hopefully. Minus 6 is equal to 156. And here I now regret. Why did I multiply 12 and 13? I don't want to multiply 12 and 13 anymore. I'm going to call it 12 times 13. You know why I don't want to multiply them anymore? Can anyone tell me why I actually prefer to write it this way? I see that some people have already figured out the answer, but why do I prefer to write it this way? It's nice. If I write it this way, what do you see about this equation? Add 6. I could add 6, but why did I think writing it this way? Factor. Vera Wang is right. There's a factor of 3 here. There's a factor of 3 there. And there's a factor of 3 there. So let's divide by 3 on everything. And if you divide by 3 on everything, you just get A plus B plus C plus D minus 2 is equal to 4 times 13. 4 times 13 is 52. That one you can maybe do in your head. 4 times 3 is 12, and then carry the 1 on the 4, 52. So then I find out that A plus B plus C plus D is just equal to the 52 plus a 2, and that's 54. Okay, and that finishes this question. That was a nice question. I'll be honest, when I first saw this problem, I thought that I would have to do a lot of random guessing. I didn't know it was going to be nice. I just saw there was A, B, C, and D, and there's 4 unknown things, so I don't know what to do. But it turns out it's not bad. We just had to go and fight with it. So thank you for the question. What else should we do today? More questions. Oh, a geometry question. I like these because I don't really know what they are. Whenever you guys ask me these geometry questions, you write words, because I don't think anyone has figured out how to draw pictures in YouTube comments. But you write these words, and based on these words, I have to try to draw a picture, and then I'm just curious what it's going to look like. Let's try this problem. Geometry problem coming. And this is by Eric Tin. There's a triangle, ABC. Oh, this is a really neat triangle. This is the 13, 14, 15 triangle. 13, 14, 15 triangle. That looked terrible. I think the 13, 14, 15 triangle looks, that probably looks exactly the same to you guys. But anyway, let's do this. That didn't look quite right either. Take that back. Oh, that was actually what I wanted. The great thing about drawing on this board is that you can not only undo, you can also redo. So let's do the 13, 14, 15 triangle. That's 13, this is the 14, and this is the 15. Let's pretend that was kind of drawn to scale, okay? So I've got, oh, Brian Lee drew a triangle. Mad skills. Okay, Necromancer also drew a triangle. obviously you guys figured out how to draw triangles. And redo is one of the best tools ever, because sometimes you undo and you're like, oh no, I need to undo. Okay, back to this. We have a triangle ABC. AB is 13 and BC is 14. That means it goes this way. ABC. Okay, we got ABC. And now M is the midpoint of BC. So there's an M here. Let's get a different color. M. M for midpoint. M for midpoint. It makes sense. Okay. Now P is a point on the segment AM. Oh, I've got to draw a segment AM. That's like this. Now I blocked my M. So I'm going to draw the M over here. I'm going to erase the 14. And then I'm going to rewrite the 14 underneath. So the problem is coming together. And what are we doing here? P is a point on AM, so that the angle BPC plus BAC is 180 degrees. Oh, now I know what's going on. I need more space. So this is M. And this was 14 across, okay? That's important. There's 14 across there. But what really is going on is that there's this line AM. No, wait, now I'm a little confused. BPC plus BAC. Oh. Okay, I see. There's 180 degrees adding together. All right, I understand what's going on. We'll do a 14 for the whole thing down here. I might need to erase it soon. But we're going to do something else where we're going to say there's a 180 degrees here. How should I do that? Let's pretend we did this. P. And what's going on with this thing that we've just drawn is that this angle plus this angle adds up to 180. That's what we're given. This plus the thing with 2 ticks is equal to 180 degrees. Okay? So now if I have this, we need to find MP times MA. Oh man. Okay. This is interesting. So you want to know what's the product of MP and MA. Equals what? Oh no. How would you ever do a problem like this? Now what does it mean for these two angles to add up to 180 degrees? I'm looking at this. I'm trying to think, is it similar triangles? So there's something that's useful, which is now showing us that we've done something here where we've gone into some pretty difficult mathematics. Okay. So when I say we've gone into some pretty difficult mathematics, yeah, okay, I got it. Right. So we've gone into some pretty difficult mathematics, but let me go and talk about it, okay? So there's something about this, like, this angle plus this angle is 180 degrees. How could you ever use 180 degrees? Well, actually you can draw a circle around A, B, and C, and that'll be interesting. Let me draw another picture, okay? Here I'm going to draw the circle first, and I see that V4913, one of the moderators, has that suggestion as well. But we can draw a circle. Kind of a lumpy circle, but I hope it's okay. So now if I have a circle, and if I go and take this thing over here, which is part of a triangle, but I'm not making a triangle out of it, I'm just going to do this. I've just done something called draw a circle with a quadrilateral inside the circle. This is called a cyclic quadrilateral. I have space under here. Good. This is called a cyclic quadrilateral. And as you learn in any geometry class, whether in school or in my class, or you can look it up online, in a cyclic quadrilateral, the opposite angles add up to 180. That's a really important fact. Dr. Gupta, thank you very much. And so in fact, whatever that angle is, this angle here is the same one as that one that's drawn here. So the important thing is, if I went and drew a circle around here, then something neat would happen. If I drew a circle around here, then, if I were to just continue this all the way down and hit the circle, then I'll get a equal angle. Let's try that. Now I'm going to erase this 14, okay? And now I will attempt to draw a circle. This is now hard. You see, because if the circle is there first, it's very easy to draw the circle. If the circle is there afterwards, it looks sort of like a lump. Sort of. Okay, sort of. Not great, but that's supposed to be a circle. So now if I drew that circle around, there's something interesting that happens. Let's continue this line all the way, and let's draw this part. Oh, hey, this has to be the same angle. Okay, so here's something interesting. What I've just drawn here is I just went and, I made the circle go all the way around. I drew this line going all the way through, and where it hit right here, guess what? This angle is the same as that one. So what do I actually have? What I actually have here is a parallelogram. You see, what I have here is that these two are equal. These two segments are equal. What else do I know? I know that these two sides are the same. I'm trying to think of whether this is indeed true. Let me see. I want to say it's a parallelogram. How would I know it's a parallelogram? Do I know it's a parallelogram? Maybe I don't. But I think I should. Yes. So this one is supposed to be a parallelogram. And how would I know that? The way I would know that is I have this line which is going here. Yes. So what's going on is that I have this line that's running right through here. And I can now use this thing called, can I use congruent triangles on this? I'm just looking at this carefully to try to decide how is the best way to explain this. I have equal angles on the opposite sides. I have one common side. It would be great if I knew that this length was equal to this length. So effectively what I'm doing here is I'm trying to show that these two things are the same picture. And it should be by a method that's called reflection. Yeah. So what's going on is that if I wanted to know how do you draw this top triangle, if I have a line that goes through here and goes through the midpoint M, and if I already know that this here makes this particular angle, if I want to know what point on this line, this part of the line, will make the same angle, I just take this thing and flip it over. And the reason I just have to flip it over is because M is already the midpoint of these two. M already happens to be the middle. And that's why all I have to do is just flip it over. If I flipped it over, then this part would just become that part. Did this make sense to people? I'm emphasizing that the picture I drew here, if I just take it and rotate it 180 degrees up there, well, of course, whatever was here, if I rotate 180 degrees around M, I'll get up there, and this part will go there, that part will go there, the angle will go there. So I've just went and shown that this is making, this part just reflects over to that part. Reflects meaning reflects through the M or rotates 180 degrees. But regardless, how do we know it's on the circle? Thanks for asking. Kirsten, the reason why you know it's on the circle is because whenever you have what's called a cyclic quadrilateral, then the opposite angles add up to 180. That's only one direction of a theorem. Another direction of a theorem is whenever you have two angles that add up to 180 and they make a quadrilateral like this, then in fact, this is on the circle. So this is a fact about cyclic quadrilaterals that you learn when you go to geometry class. And indeed, V4913 has another way of writing down why this is congruent. But the important thing is that now I know that this and that are the same. Now that's powerful, because that means that this PM, this MP, is the same as this other thing, whatever that is. Let's call it Q. Let's give this a name. Let's call this point Q. So now that's exactly the same as MQ times MA. Why does anyone care about that? Well, the reason why that's good is because MQ times MA happens to satisfy another famous theorem about circles. Does anyone know what I'm talking about? If I have a circle, also known as a circular lump. Okay, I've got this circle here. If I've got this circle, and if I have two lines, one that goes through here and one that goes through there, there's a very important thing that you can do about multiplying lengths. If this length is A, and this length is B, that looks like a weird B, that looks like an even more weird B, and this is a C, and this is a D, there's a very important fact, also proved in our geometry class or in any geometry class, Cayley CSA's, power of a point. This is a very powerful theorem. Okay. PowerPoint. Power of a point. Power of a point tells you that A times B is always equal to C times D. Okay. So in that case, how can I finish this? So if I now know, and yes, you can prove this with similar triangles also, but because this is a daily live stream, we don't have time to go through all of those proofs. Those are all in the class. Vera Wang says you can call this PowerPoint. Anyway, so if I want to multiply this by this, it would be this times this. So what's the answer? Are we done? I think we're done. Because what is this? MQ times MA is the same as MB times MC. Can anyone tell me what MB times MC is? That's not bad. I already erased it. But the whole thing was 14, right? So it's just 7 times 7, 49. Which is 49. And I think that's the answer to the question. Oh, I thought we were actually going to use the 13, 14, 15 triangle in a more fundamental way. I didn't realize that we were just going to, I didn't realize we were just going to need the 14. If you look at it, I don't think we even really needed the 13 and the 15, did we? I think this is true if you just go and do anything you want with A, right? So this problem wasn't that bad. This wasn't that bad at all. But I wanted to tell you that the 13, 14, 15 is a really nifty triangle. Does anyone know that the 13, 14, 15 triangle is made by putting together two triangles? Let's just mention that. Famous, interesting fact. 13, 15, 14. 13, 15, 14 triangle. This is a really neat triangle. I can make it by putting together two triangles. Now, suppose I drew this thing down here. Yes, thank you, Springfield Chinese. 5, 12, 13. And if I want a right triangle with 12 and 15, that's like a 3, 4, 5, where this is like the 4 and that's like the 5, which means I'm multiplying everything by 3. So that means this is 9. And indeed, 5 plus 9 is 14. So this is in fact two nice right triangles jammed together. Okay, that was fun. More stuff. Use the 14, you're saying. More questions. Oh, Dayit asked, but how do you know they are bisected? If you were asking about the previous thing, what I was saying is that if I drew a picture like this, and I chose to rotate 180 degrees around the M, I would make a point which is on this same line, right? It would be on the same line, Q, M, and something. They would all be on the same line. If I just took this, rotate 180 degrees, I legitimately get on that line, and I also legitimately get the correct angle. This and that would be the same. And there's only one point on that line which makes this particular angle. Like the farther up you go, the smaller the angle. Closer down you go, the bigger the angle. So that's how you know. Okay, more questions. Fayad Sardar asks, how to multiply two or more than two numbers without using calculator in only 15 seconds? Well, that's a pretty tough question, because if your numbers get bigger and bigger, it'll take longer and longer to multiply. So I don't actually have a good way to answer your question of how to multiply two or more than two numbers in only 15 seconds. I think whenever you multiply numbers, you just use whatever trick seems the best. Of course, Daksh Gupta says that he can multiply three numbers in less than 15 seconds, as long as one of them is 0. But I have a feeling that you were asking for non-zero. Oh, interesting. Sophia was asking, by the way, on this, could we use trigonometry to measure angle A? You could, but as you can see, you didn't need it. Okay, more questions. It's a probability question. I wonder what the answer is. So this is by Andrew Chow. Andrew Chow says there are 3 dice. They're normal dice. 3 normal dice. That sort of rhymes with 3 blind mice, but that's totally different story. But 3 normal dice. And you're going to roll them. And you want to know what's the probability that the sum of 2 of the dice equals the third. That's a strange T. Sum of 2 equals the third. Okay. With all of these questions, what we have to do is we have to go and, I guess, figure out what are the number of possibilities divided by the number of things that work divided by the number of possibilities. You're saying casework. It might be, it might not be. Let's go and find out. So if I want to do this, I also realize I need to be careful of order. Or do I? Ooh, I have an idea. So here's what I'm going to do to solve this problem. How many possibilities are there? There are 216. 6 times 6 times 6. Let's do that first. Get that out of the way. So the total possibilities is equal to 6 times 6 times 6, which is 216. Now, what do I do with this? I'm going to say, oh, could you use complementary counting, asks Min Ko. I don't think that'll be as nice, because whenever I want to use complementary counting, I want to have something where the complement is easier to count. But to say that the sum of 2 is not equal to the third, that's actually more difficult, I think. So let's go and split by, let's do the first case, which is that the third is the third, like the real third, right? This is asking what's the sum of the probability that sum of 2 of them equals the third. But it could be that the first and the second die add up to the third, but it could also be that the second and the third die add up to the first. But I'm basically going to take the whole answer and times 3. I'm going to figure out what's the probability that the sum of the first and the second equals the third, and then times 3. So how to do this? Just count the number of ways to add, not to add, to have the first plus the second, and that to equal the third. Okay, so if I want to do that, I need to figure this out, and then I'll take that answer times 3, and then I'll divide it by the total possibilities. Okay, so we do have to remember, then we will times 3, and then we will divide by 216. Is everyone okay with this so far? I just need to do this because it's like, well, which is the sum? The sum is either the third one, the second one, or the first one. So we're here. So now I have some cases. What could the third be? Let's go and find out. Case time. If the third is equal to 1. Can anyone tell me how many ways there are to do this? If the third is 1, how many ways can you have the first plus the second equals the third? This one's okay, 0. There's no way, because you can't have like numbers which are 1 or more and add up 2 of them and get 1. So there's no ways. As you can see, it's going to be actually pretty systematic. If the third is equal to 2. Can anyone tell me how many ways could I have the first and the second to add up to 2? This is okay. If I want the first and second to add up to 2, that's 1 plus 1 equals 2. That's the only way. One way. If the third is equal to 3. Now here's where the order is important. It's because I have the first and the second, right? So if I have the first and the second, it could either be 1 plus 2 or 2 plus 1. 2 ways. That's 1 plus 2 or 2 plus 1. Are people seeing a pattern? If I have a 0, a 1, and a 2, then the next one must be 17. No, it's 3, right? It's 3. So it's always plus 1. Always one more way. It always makes sense. Okay, so if the third is equal to 4, it's either going to be 1 plus 2. Think of what I start with. 1 plus 2 or 2 plus... Wait, I can't add. 1 plus 3 or 2 plus 2 or 3 plus 1. Right, so 3 ways. Yes, 3 ways. I just have to add stuff now. If the third is equal to 5, 4 ways. And finishing all the way back around, if The third is equal to 6. 5 ways. Okay, so I just need to go and add up these 0 through 5, add them up. I see a bunch of people like Dr. Gupta say that's 15. And you can do that any way you like, but add all of this together, you get 15. And so the answer is 15 times 3 divided by 216. And that's where maybe I'll regret that I actually multiplied the 6's together. Now I want to cancel stuff. So I'm going to go back and rewrite it where I cancel. Okay? So I really have answer. That's a funny W. That's equal to 15 times 3 divided by 6 times 6 times 6. And now if I do some cancelling, what happens? The 3 takes away a 2. That leaves a 5. That leaves a 2. And so what I have here is 5 divided by 6 times 2 times 2. 6 times 4 is 24. Oh, that wasn't so bad. In fact, I think I might have seen somebody in the chat write 5 over 24. Is that actually right? I see that people have other things in the chat. 45 over 216. Could that be right? Maybe I have a mistake. If I have a mistake, please let me know. You know I make mistakes all the time here. But let's see. Let's look at it. I think it's okay. 6 times 4 is 24, and on top is 5. So I think the answer is 5 over 24. And the thing to be careful about whenever you do these kinds of questions is you need to go and pay attention to, the order. Right here we saw that you can have the first and the second add to the third, but the sum can be any of them. That's why there's a times 3 here. Okay, more questions. What else did people ask today? What kind of question is this? Ethan Cao, Po the dolphin is teaching his IMO team when he receives news that scientists have found a new species of bananas. He is so excited, he decides that he will go and taste one. What is his chance that they let him? I'm not sure that there was any particular mathematics in here, but I think what I'll say here is maybe I'll tell you that the answer to this question is 500%. Now I'm going to use that to illustrate something. I just told you that something's happening with 500% chance. That's not possible. Well, you see, here's what I'm trying to illustrate. You gave me a premise. You told me a bunch of stuff that's true, which is like not possible. It's not possible that Po the dolphin, first of all, who's that? And do dolphins have IMO teams? Not that I've heard of. Scientists finding a new species of bananas, that could indeed happen. But I'm trying to say, like, if the premise, like if you have a statement that says if something, and the something never happens, well, then you can say anything you want. I mean, here's something that's true. Did you know that if 1 plus 1 equals 3, if 1 plus 1 equals 3, then 1 plus 2 is equal to, what is that equal to? I don't know. It's really confusing. 4. So what I just wrote is I wrote like, if something, but the something was false. So you can actually write this down. This is a true statement. This whole thing I've written down is actually true. This is true. But the reason why I pressed undo. The reason why this is like not very interesting is because, well, it's a true statement that if 1 plus 1 equals 3, then that's true. But it's kind of useless because 1 plus 1 is not 3. Do you see what I mean? And Temp ID is saying this. It's like if something is false, then false stuff is okay. Because whatever math says, math just says if that were true, then that's okay. But it's not. So anyway, so that's why my answer to your question, I decided to illustrate this by giving you nonsense. I gave you 500%, which is not an actual percent. But that's okay, because I don't know about Po the dolphin's IMO team. All right, more questions. So many interesting questions today. I see Vera Wang is asking false and false cancel out. Well, the important thing, maybe while we are talking about logic, whenever you have if something then something, all that means, any statement, let's talk about that carefully, because that's actually interesting, right? You'll often see some things like, if A, then B. What does this mean? It just means that you never have that A is true and B is false. That's all that means. Means that you never have A true but B false. So that's how you think of these things. It's like that's what it means, if this, then this. And so if you're ever curious, like, what should I do with these like if then statements, just think about it as saying, like, what would it mean for it to break? And how you break is that, hey, this was true, but that didn't happen. Okay. More questions. Yes, exactly. As Turtle Link is saying, the thing about these kinds of logical statements is that if A is false, you can do whatever you want with B. Okay. Oh, Minko asks a general question. What do I think is more important for kids learning math? More depth, where you dig deeper, or more width, where I guess you see more different topics? I think, to me, the depth and the width are related if all you're doing is exploring new things. And not exploring new things, exploring thinking by yourself. Like what you're seeing today. We're basically just doing all these random questions which are coming in, and we're talking about the topics as we're using them. But sometimes these are going kind of deep. It's like what we had to do in order to solve that geometry problem is we actually dug fairly deep into geometry. We used cyclic quadrilaterals. In fact, that geometry problem is a pretty hard one. But I would say that's a good way to learn. A good way to learn is to do these challenging questions. And where can you find them? You can find a lot of these in math contests. So I strongly recommend playing with the old questions from these math contests. They're quite good. Okay. More questions. Oh no, Ethan Tao. Po the dolphin answers my question. He answers 500%. What is the chance that he will answer this problem with 500% again? Now that is a deep logical question. So what you just said, okay, so you see, by the way, that has now happened, all right? Because I did answer your question with 500%. So Ethan Tao says, I've answered 500%. What's the chance that I'll answer the problem with 500% again? Well, if I told you the chance was 100%, that's not true, because I would have said 100%, and that's not 500%. So it's not true. So the correct answer to that question is actually 0%. Does everyone get this? I've now legitimately answered your question. Your question was this. If the previous question, Q stands for question, was answered with 500%, what's the chance that this question gets an answer of 500%? So you see, my logic was the answer is not 500%, because if I said the answer was 500%, then the chance is 100%. Do you see what I mean? This is like one of these very meta questions. It's like, if I told you 500%, no, it actually happened. And that means it's 100%. And that's not good. And I mean, there's either going to be an answer or not. So I guess it's 100% or 0%. I'll tell you it's 0%. The chance that I would answer you an answer of 500% is actually 0%. Because that's the only one that makes sense. You see, like I can't tell you 100%. And if I told you anything that was less than less than 100%, okay, well then that's not going to be 500%. So it has to be 0%. So the answer to this is 0%. And indeed, that's what I did. I told you 0%. And I was also right. Did this make sense to people? Okay, more questions. I see that there are a lot of these geometry questions here. I'm just going to stay away from a bunch of them for now, because I know that the audience which watches this live stream has a variety of experience. And that one geometry problem we did already today is already fairly challenging. What? We have a new broken calculator. Jack E. Oh, Jack Y. I was dumpster diving. Be careful of dumpster diving. Dumpsters can be dangerous. What that means is you went looking in the trash for interesting stuff. And the interesting stuff that Jack Y found was broken calculator. And this broken calculator says 4 equals 1. 3 equals 3. This calculator doesn't even have any addition. It's just like you put a number in. Fun. 5 equals 0. And the question is, what does 6 equal? What? All right. Fortunately, we have a lot of very creative people here. So now let's go and start thinking about this. How could this be reasonable? 4 is 1, 3 is 3, 5 is 0. Oh boy. To me, it's a little bit funny that it goes 4 and then 3 and then 5. I would flip them around and I would say 3 is 3, 4 is 1, 5 is 0. 3, 1, 0. What is this? Some people say, what if the keys are shifted in some funny way? But if the keys are shifted in some funny way, why would 3 be 3? So I see some people, it's like, yeah, we need to think of this as a function, right? So there's a 3, 4, 5, and 6. And there's like a 3, and then a 1, and then a 0, right? So we have like 3 goes to 3, 4 goes to 1, 5 goes to 0. I'm pretty stumped. Let's see. Yeah, 3 is in the original place. I agree. 3 gives you 3. Oh. Skylar Shred thinks it goes 6, 5, 4, 3, 3, 1, 0, minus 1. Weird functions. So I'm afraid that I actually don't see a great way to do this. I see a lot of people like 5. Does anyone want to tell me why you think it's 5? As you can see, we're just being creative here. Somebody made a difference table. But I guess I don't really know why it would be 5. So I'm going to say I'm stumped. Jack, why? I don't know. What's the answer? Rotation about 3. I don't know. I mean, I think I just don't see a nice pattern here. 4 plus 1 is 5. 3 plus 3 is 6. 5 plus 0 is 5. So 5. So I actually don't know the answer. Roman numeral. There's Roman numerals here? V, IV. Oh, whoa, that's interesting. So what you're telling me is that 4, 3, and 5, and 6? Is that what you mean? I mean, maybe that's true. In that case, I think that's a legitimate answer. It's the number of eyes. Let's just use that. It's the number of eyes. Maybe. I'm just making this up. But I think what we're seeing here is I don't really see a reasonable pattern, but this one made sense. So let's go with this. And let's just continue. I'll say maybe the person, oh, it was right? Jack Y says it's right. That means that somebody here has some kind of an ESP connection with Jack Y. I don't know how you thought of this, but whoever figured this out, you're pretty good. Okay, let's keep going. More questions. Oh, neat. I see a geometry problem, but this geometry problem isn't really, like tons and tons of lines. It's about what would happen if aliens came. So we have this question. It's by Mark Alley. So suppose that we have a Earth. Is that okay? Sort of lumpy, but that's going to be a circle, okay? Suppose you have the Earth. And suppose you are at distance r above a planet of radius r. It does look kind of lumpy. Anyway, so this is r, and then you have some aliens which are out here. So you have some alien, right? So we have some aliens, and you have like their distance r away from the planet, and the planet has radius r. Yes, Earth is not a sphere, thanks Anna Howe, but we're okay here. Lump tune, you guys are very funny. So we have this thing, and what we're going to say is, the question is, how much of the Earth can you see? The question didn't really specify what how much means, so I'll just talk about angles. So the question is, how much of the planet can this alien see? The alien apparently has 2 heads, so the alien can see pretty well. So the question that I'm going to interpret this as is, what's the angle that we have there? Is that a 2-headed man? No, that's a 2-headed alien. Okay. So now if I'm over here, somebody said that Earth is flat. If I've got the 2 tangents theorem, I think what we're talking about is their tangents. This one goes right over to there, and it's a tangent. So that means it's a right angle over here. So if I were to draw this, that's a right angle. And if I were to draw that, that's a right angle also. But those are radii, r and r. Okay, so now what kind of triangles are these? This is 2r, and that's r, and that's a right angle. So that's a nice kind of triangle, right? If it's double and then single, it's like 2 and then 1 and then square root 3. In fact, this is half of an equilateral triangle. 2, 1, and then square root 3. So this thing here is 30 degrees. There's a stray r over here. Let's just write the r somewhere else. And this is, let's just erase the question marks. This is 30, and this is 30. So that means that the 2-headed alien can see a 60-degree angle looking at the Earth. And I'll use that as the answer to the question. It's like, how much of the Earth can you see? You can see up to 60. Oh, you know what? That's not a satisfying answer, because that's not talking about the Earth. That's like from the aliens' point of view, and who cares about the aliens? So let's change it. Actually, what we care about is what this is. How much of the Earth can the alien see over here? If you want to know this part, well, that's 30, so that's 60. These are 30, 60, 90 triangles. Pretend that was 60. So what you really have is you have 120 degrees of the Earth. You have a third of that entire circular angle. And that's what the aliens can see. Okay, more questions. Vera 1. What is the chance that there are 9 planets, excluding Pluto? That's a good question. I don't know. I don't really know how easy it is to detect the amount of mass in the solar system, but I believe that astronomers have been thinking about this for a while. So I don't know a good answer to that. And of course there's the question of, is there like some other planet out there that people haven't discovered yet because it's so far away? I don't know enough about astronomy to give you an answer to that question, but it's pretty interesting. Here's an interesting one. This is by Moonlight 7 Gifron. How many ways to choose 5 books from 12 if no neighboring books are chosen? So you want to say 5 books from 12. So there's 12 books, and you want 5 of them. Let me first try to pack them really close together. Wonder if this is the way to put it. So you're saying how many ways to choose 5 books from 12 if no neighboring books chosen. Okay, so if I have 12, I'm first going to try to pack them all as tightly as I can. I'm just kind of curious what this looks like. If I pack them as tightly as I can, I think I can put 9 books. Because I can get 5, and then I kind of squeeze in, these gaps in between. And I don't like to think about it that way. So the way I usually like to think about this is I like to think I'm trying to find out how to pack this in a line of 13. So I'm going to change the question. into how many ways to express 13 as the sum of 5 numbers from 2 or higher. I claim these are the same problem. Why do I say that? They're the same problem because if you think about how you're choosing books, there's 12 spots. Slot number 1, slot number 2, slot number 3, all the way to slot number 12. Now, if you're going to choose the books, you could choose, that book right there, but then you can't choose the 2. So maybe you choose that book there, and maybe you choose that book there. And what I could do is I could even think of these as like, this is a block. It's a block of size 2. And I don't know, maybe there's a block here of size 3. Does this sort of make sense? If that's a block of size 2, that's a block of size 3. And I say block meaning the x, and then it's not a choose problem, by the way. It's an x here, and then there's like an empty space, and I say that's a block. A block is a blank space, bunch of blank spaces, followed by an x. But it's really weird to say that that's a block of size 1, because all of these other blocks are not allowed to be 1. Does that make sense? Anything else here is not allowed to be 1, because 1 would mean x and no blank space and another x. Not okay. So in order to go and fix this, I'll add a 0 slot. This is a fake slot, but I'll always include that in that block. So now I'm saying, I'm just going to say, how many ways can I get to 13 as the sum of all these blocks? Ooh, what if the 12 is blank? Thank you, that's a great question. So the 12 could also be blank. So I will say express a number less than or equal to 13 as the sum of these. Now this is better. Okay? Thank you very much for bringing that up. You are right, because the last one doesn't have to be used. But if I finish earlier, I finish earlier. It's like doing your test fast. Okay, so now I just want to know how many ways can I do this? I get to use 5 numbers, and they're like 2, 3, 4, and so on. So here I'm going to do it sort of by cases. I'm like, okay, how could you do this? And there might be more efficient ways, but I'm just going to do this quickly because, well, you know what? There is actually a nice way to do this. There's a nice way to do this systematically, but we won't have enough time to talk about it today. That systematic way happens to have a name. It's called dynamic programming. But the reason I'm willing to do this non-systematically is because of the 3-minute warning and because the numbers are kind of small anyway. Famous last words. Let's try. So what we could do is we could do 5 numbers, all 2s. And I say that's one way. The reason that's one way is because, well, I can't reorder them. They're all 2s. The next thing is I can say, let's get a little bit bigger. By the way, this is sum of 10. So now let's get a bit bigger. Maybe I get a sum of 11. 2 plus 2 plus 2 plus 2 plus 3. That adds up to 11. How many of these are there? I want pink. How many of these are there? There are 5 of these. The reason there are 5 of these is because I can put the 3 anywhere I want. Okay? So now that's a sum of 11. Well, what's next? Sum of 12, right? Because that's the only way to get sum of 11. How do I get sum of 12? There's actually 2 ways to get sum of 12. One way to get sum of 12 is 2 plus 2 plus 2 plus 2 plus 4. Another way is 2 plus 2 plus 2 plus 3 plus 3. Those are the only 2 ways to get a sum of 12. It's not that much fun to do it this way, but I saw the numbers are small enough that this brute force will work. The number of ways to rearrange this is also 5, because the 4 could go anywhere. How about this? This is a choose problem. I have 5 slots, and 2 of them are going to be 3s. So it's 5 choose 2, which is 10. 5 things, I choose 2 of the spots to be 3. And let's finish. The finish answer is coming wrong. I'm not sure. So let's finish this, right? The way to finish this is you say, okay, how about the sum being 13? Well, there's a few ways to do that. It could be 2 plus 2 plus 2 plus 2 plus 5. That's the sum of 13. Or I could have 2 plus 2 plus 2 plus 3 plus 4. Okay. Is that the only way? Let's see. Are there any others? Help me, guys. So I have either 2, I put a 5, or I take away one of the 5 and I get 4 and 3. Ooh, there's another way. 2 plus 2 plus 3 plus 3 plus 3. I think those are all of the ways, okay? And that's the only way I can make the 13. So now let's go and do it. How many of these? There are 5 of these. How many of these? Oh boy, this is 5 factorial divided by 3 factorial. If you do that slowly, 5 times 4 is 20. I'm just doing this fast now. This is 5 choose 2, which is 10. And if you go and add everything together, 1, 5, 5, 5, that's 15, 16, 16 and 40, 56? Was the answer 56? I'm actually curious. I don't know if the answer is 56. We're over time, but I'm curious what the answer is. Is the answer actually 56? If I add all this stuff together, sum might be 56. I might have made an arithmetic mistake. Maybe I made an arithmetic mistake, but it looks pretty good. And so this is how one could do this. Thank you to everyone for joining us for this week's Ask Math Anything. And if you had fun, well, I hope that you'll come next time and ask more anything about math. See you then. Take care. Bye-bye.